In this video, we'll look at probability distribution and expected values. So expected value of x and the expected value of x minus mu squared. And so one of them will give us the mean, the expected value of x, and the other will give us the variance, the expected value of the x minus mu squared. So basically what they are weighted averages. But let's look at just the probability distribution and making sure we can find probabilities based on what we have here. I've got a distribution here of vehicles needing brake service for each day at a particular shop, and this is the probability that was determined over many days. They've determined that 27% of the time there's going to be 3 cars that need service. 2% of the time there's going to be 6 cars. And it has ranged from anywhere from 0 to 6. So those are all the possible values. So from this distribution, I obviously computed a cumulative probability distribution as well. Okay, so we can look at them either way. We can find probabilities from either one of these distributions. So, for example, probability x equals 4. Well, that one we'd probably want to look at the probability distribution here. Just go to 4, and you can see that that's 0.17. Probability x is less than 4. Well, for a discrete random variable, that is not including 4. That's going from 3 down. So we have the cumulative here of probability x is less than or equal to 3. So that's 0.7. Probability x is less than or equal to 4. Well, now we are going to include 4 here, so 0.87. Probability that x is greater than 4, well, that leaves us with 5 and 6, so you could add up these two probabilities here, or you could take 1 minus the probability x is less than or equal to 4, because this doesn't include 4, so our complement would include 4, so that's why we take 1 minus probability x is less than or equal to 4. Well, now here this one does include 4, so now you're going to take 1 minus the probability x is less than or equal to 3. Okay, or again, you could just add up these probabilities here, 4, 5, and 6. Okay, so that's finding the probabilities. And then to find expected values, well, that's just all these possible values weighted by their probabilities. Okay, now the sums, the weight, sum of the weights equals 1, so we don't even have to worry about a denominator. We just take x times the weight, in this case the probability, and then do that for every value, and you sum those up and you get 2.75. Okay, so that's our mean, that's our expected value of x, or mu, okay, because this is considered a population distribution here, so we'll call it mu. Well, we can do the same thing to get the variance. We know that the variance deals with how x deviates around the mean, so we'll take each value minus the mean, so we'll freeze that, copy that down. Okay, but now we have to square each of those. Okay, so do that for every value, for every deviation here. So there's the squared deviations, and now basically a variance is the expected value of this here. Okay, so we're going to take each one of these values times the probability. So that times probability, and we'll bring that down. And now the sum of those is 2.0875. So that's our variance, sigma squared, and then obviously the square root of that is our standard deviation, sigma. Okay. Now, in the notes, I also show you a shortcut method. You can decide whether it's really a shortcut based on the few numbers that we deal with here. But what we need for that is the expected value of x squared. So what you have to do is take each value squared times the probability. So you're doing the same thing as right here, but you're multiplying x squared times the probability rather than x times the probability. All right. So the expected value of x squared is 9.65. Now in the notes, you hopefully saw that the variance can be found by taking that 9.65 minus this 2.75 squared. And there's your 2.0875. And so you can come up with variance either way. So I hope this helped in figuring out how to calculate expected values and to make sure you understand probability distributions. Let me know if you have any questions.